Today we are embarking on a fascinating journey towards humanity's new frontiers. Space colonization projects are no longer just a dream seen in science fiction films. They are becoming a vision turning into reality. With advancements in technology, plans for colonies on the Moon and Mars, asteroid mining, and even sustaining life on distant celestial bodies like Europa and Titan are now on the scientific agenda. In this video, we will cover many topics, from the history of space colonization projects to the latest developments, the challenges faced, and the technologies needed to make this dream a reality. So, is humanity ready to build a new home in space? Let's find out together. Space colonization, as the name suggests, refers to the efforts to establish new living spaces for humanity beyond Earth. But why do we want to establish colonies in space? The answer lies in both practical and philosophical reasons. Firstly, our planet's resources are limited, and our population is growing. The risk of resource depletion on Earth drives people to seek alternative living spaces. Establishing colonies in space could be a significant step in solving this problem. Moreover, in the face of global catastrophes, climate change, and natural disasters, humanity may need new living spaces to survive. Philosophically, humanity's spirit of exploration and desire to understand the unknown make space colonization appealing. By continuing the legacy of our ancestors who discovered new lands and pushed boundaries for centuries, it's now time to build new homes in space. Space colonization offers an exciting opportunity to understand and expand humanity's place in the universe. In this video, we will explore in detail what space colonization is, why it is important, and the major projects in this field. If you're ready, let's continue this fascinating journey. The idea of space colonization began with humanity's fascination with the sky. This curiosity has driven scientists and visionaries to deep thoughts and discoveries for centuries. By the mid-20th century, space travel had become more of a reality than a dream. In the 1960s, as the space race was in full swing, science fiction works inspired this race. Authors like Arthur C. Clarke and Isaac Asimov imagined colonies in space and incorporated these ideas into their works. These stories inspired many scientists and engineers. The Apollo 11 moon landing in 1969 was a significant milestone in space exploration. Neil Armstrong's first step on the lunar surface was humanity's first step beyond Earth, and made the idea of space colonization more tangible. This success encouraged scientists to seriously consider colonizing nearby celestial bodies like the Moon and Mars. In the 1970s, NASA and other space agencies began researching the establishment of permanent living spaces in space. Concepts like O'Neill cylinders, which are massive structures rotating in space with habitable areas for humans inside, were proposed. However, these projects couldn't be realized at the time due to technological and financial limitations. Today, with the advancement of technology, the idea of space colonization has resurfaced, and work on many projects has accelerated. Space colonization is no longer just a dream of science fiction writers, but a concrete goal that real scientists are working on. Now let's focus on the moon colonization projects. The Moon, being the closest celestial body to Earth, is seen as the first target for space colonization. In this section, we will delve into the details of the plans for colonizing the Moon. NASA's Artemis program aims to send manned missions to the Moon and establish a sustainable living environment there. The Artemis program began in the early 2020s and was the first major initiative aimed at returning to the Moon. One of the main goals of this program is to establish a permanent base on the lunar surface, and use this base as a stepping stone for future missions to Mars. Under the Artemis program, multiple manned and unmanned missions are planned on the lunar surface. Initially, astronauts will be sent to the south pole of the Moon to explore the water ice present there. Water will be a critical resource for sustaining life on the Moon. It can be used as drinking water and can be split into oxygen and hydrogen. In addition to NASA, private companies are also making significant strides in establishing colonies on the Moon. For example, SpaceX's Starship vehicle plans to transport large amounts of materials and people to the moon. Blue Origin's Blue Moon project aims to send materials and equipment to the moon. These projects will provide the logistical support needed to establish permanent living spaces on the moon. Other necessary infrastructure for colonizing the moon includes energy production, construction materials, communication systems, and life support units. Solar energy is seen as one of the most suitable sources for meeting the energy needs on the moon. Additionally, the lunar regolith, a type of soil on the moon's surface, can be used as construction material and employed in building structures using 3D printing technology. Moon colonization projects offer a great opportunity not only for scientific research, but also for testing humanity's ability to establish a sustainable life in space. Successfully establishing a colony on the moon will be a significant step for colonization projects on Mars and more distant celestial bodies. Our next stop is Mars, the red planet of space. Mars has long captivated humanity's curiosity and has been a target for dreams of colonization. In this section, we will explore Mars colonization projects and their details. One of the most ambitious Mars colonization projects is led by Elon Musk, the founder of SpaceX. SpaceX aims to establish a permanent human colony on Mars and make it self-sufficient. Musk's vision includes building a large city on Mars where millions of people can live. The Starship rocket, developed to achieve this goal, is designed to transport large amounts of cargo and people. Starship aims to speed up the colonization process by organizing regular missions to Mars. NASA also has significant plans for Mars. The Mars 2020 mission, which includes the Perseverance rover, was sent to Mars to search for signs of life on its surface and pave the way for future manned missions. NASA plans to send humans to Mars by the mid-2030s. These missions will explore the water resources and other vital materials necessary for sustaining life on Mars. The sustainability of life on Mars requires overcoming many technological and scientific challenges. Mars's atmosphere is much thinner than Earth's and consists mainly of carbon dioxide. Therefore, developing life support systems and oxygen production on Mars is crucial. Scientists plan to use the water ice on Mars to produce oxygen and hydrogen, which can be used for both life support systems and rocket fuel. Various methods are being explored for energy production on Mars, including solar panels and nuclear energy. Solar energy is one of the most suitable options for meeting the energy needs on the Martian surface. Additionally, 3D printing technology can be used to produce construction materials and build structures on Mars. This technology enables the use of local resources for construction, reducing logistical costs. Mars colonization projects offer a great opportunity not only for scientific research, but also for testing humanity's ability to establish a sustainable life in space. Successfully establishing a colony on Mars will be a significant milestone for humanity's future in space. Beyond Mars and the Moon, there are many intriguing and potentially habitable celestial bodies for humanity. In this section, we will explore colonization projects on asteroids, Europa, Titan, and other celestial bodies. First, let's focus on asteroids. Asteroids are rich in valuable metals and other resources. Asteroid mining could alleviate resource shortages on Earth and support the space economy. Therefore, some companies and space agencies plan to establish colonies on asteroids for mining operations. Small colonies on asteroids can serve as bases for both scientific research and mining operations. Europa, one of Jupiter's icy moons, is believed to have a subsurface ocean. Colonization projects on Europa aim to explore the potential for life in this ocean. Establishing a colony on Europa can provide a base for developing life support systems using water and ice and sending exploration vehicles into the ocean's depths. These projects represent a significant step in understanding whether life exists beyond Earth. Titan, Saturn's largest moon, has a dense atmosphere and lakes of liquid methane and ethane on its surface. Colonization projects on Titan aim to explore the sustainability of life in this unique environment. Titan's atmosphere is thicker than Earth's and can provide protection from radiation. Additionally, the liquids on Titan's surface can be used for energy production and other industrial processes. Ceres, a dwarf planet located in the asteroid belt between Mars and Jupiter, is rich in water ice. Colonization projects on Ceres aim to use water to develop life support systems and create a base for asteroid mining. Ceres's low gravity can save energy for space travel and facilitate logistical operations. These colonization projects on various celestial bodies offer great potential for researching the sustainability of life in space and expanding humanity's presence in the cosmos. Each celestial body presents unique challenges and opportunities, and scientists and engineers are working to overcome these challenges. Establishing colonies in space is an exciting and promising goal, but it also faces many technological and scientific challenges. In this section, we will explore these challenges and the solutions being developed to overcome them. One of the biggest challenges in establishing colonies in space is the sustainability of life support systems. Far from Earth, innovative solutions are needed to meet basic needs such as oxygen production, water supply, and food production. Scientists are working on various methods for oxygen production in space. One method involves splitting water into hydrogen and oxygen to obtain oxygen. Additionally, systems are being developed to convert carbon dioxide found on Mars into oxygen. Food production is also a major challenge. For long-term living in space, it is necessary to grow and produce food. Space agriculture holds great promise in this regard. NASA and other space agencies are working on plant-growing systems in closed environments. These systems aim to optimize the water, light, and nutrients needed for plant growth, enabling sustainable agriculture in space. Radiation poses a serious threat to people living in space. Earth's magnetic field and atmosphere protect us from harmful cosmic radiation, but this protection is absent in space. Therefore, radiation protection solutions need to be developed for space colonies. Various materials and designs are being explored for radiation protection. For example, thick-walled structures made using local resources such as water or regolith can be effective in reducing radiation. The lack of gravity is another major challenge for living in space. In a microgravity environment, the human body loses muscle and bone mass, leading to long-term health problems. To address this issue, innovative solutions such as rotating habitats that produce artificial gravity are being researched. Additionally, equipment that helps astronauts maintain muscle and bone mass through exercise is being developed. Finally, energy production and storage in space is a significant challenge. Solar energy is emerging as the most suitable energy source for space colonies. Advanced solar panels and energy storage systems can be used to meet the energy needs of space colonies. Additionally, nuclear energy can be considered a reliable energy source. All these technological and scientific challenges are the biggest obstacles to space colonization projects. However, the work being done to overcome these challenges will shape humanity's future in space and bring us one step closer to new discoveries. Space colonization projects are not tasks that a single country or company can tackle alone. Such large-scale and complex projects require international cooperation and solid policies. In this section, we will examine the importance of international cooperation in space colonization projects and the existing space policies. The goal of space colonization requires the collective efforts of many countries and space agencies worldwide. NASA, ESA, European Space Agency, Roscosmos, Russian Federal Space Agency, CNSA, China National Space Administration, and many other international space agencies cooperate in space exploration and research. These collaborations enable the sharing of knowledge and resources and make it possible to achieve greater goals in space. For example, the International Space Station, ISS, is one of the best examples of international cooperation. This project, jointly conducted by NASA, ESA, Roscosmos, JAXA, Japan Aerospace Exploration Agency, and CSA, Canadian Space Agency, has been a platform where scientists and engineers from different countries work together and achieve great success. The ISS has increased experience in permanent living and cooperation in space, laying an important foundation for future colony projects. International cooperation in space colonization projects is important not only in technical and scientific matters, but also in political and legal regulations. Various treaties and laws exist to ensure fair and orderly operations among countries and companies operating in space. The Outer Space Treaty, signed in 1967, is one of the most fundamental documents in this field. This treaty ensures the peaceful conduct of activities in space, limits military use, and maintains space as a domain for all humanity. However, as space colonization projects progress, new legal and political regulations will be needed. Topics such as space mining, property rights, environmental protection, and human rights will be important agendas for future space colonization. Addressing these issues through international cooperation and dialogue is crucial for a peaceful and sustainable future in space. The increasing role of private companies in space is another important factor to consider. SpaceX, Blue Origin, and many other private companies have become significant players in space colonization projects. How these companies will cooperate with public institutions and what rules will apply in space will be decisive in shaping international space policies. In conclusion, space colonization projects require international cooperation and strong policies worldwide. This cooperation and policies will secure humanity's future in space and open the doors to new discoveries. Space colonization projects will have profound economic and social impacts, not only technologically and scientifically. In this section, we will explore the economic dimensions and societal effects of space colonies. Establishing colonies in space requires significant initial costs, but offers substantial economic opportunities in the long run. Space mining is at the forefront of these opportunities. Asteroids and other celestial bodies are rich in rare metals and minerals. Bringing these resources to Earth can support industrial production and revolutionize the technology sector. For example, platinum group metals are critical for electronics and renewable energy technologies. Accessing these resources in space can significantly contribute to the global economy. Space tourism also stands out as an important economic opportunity. Even now, some private companies plan to organize tourist trips to orbit and even the moon. Initially, space tourism may be an expensive adventure for high-income individuals, but costs may decrease over time, reaching a broader audience. This can create new job opportunities and economic growth. Beyond the economic aspects of establishing colonies in space, there will also be social and cultural impacts. Living in space will require a new social order and cultural adaptation for humanity. Life in space colonies may necessitate re-evaluating existing social structures and norms. These colonies will offer new opportunities for diversity and cultural richness, while also presenting new social challenges. Social interactions in space colonies will differ from those on Earth. Isolation, low gravity, limited resources, and confined living spaces will create new social dynamics. How people will live, cooperate, and form social relationships in these environments will be a significant research topic for social scientists and psychologists. Education and cultural development will also be essential parts of space colonies. Children born and raised in space will grow up in a different educational system and cultural environment. This will shape the thinking and worldview of new generations. Art, music, and other cultural activities in space colonies will be crucial for the development of the human spirit. The impacts of space colonies on Earth should also be considered. Technological and scientific advancements achieved in space can improve the quality of life on Earth. For example, new materials and medical technologies developed during space research can revolutionize health and industry on Earth. Additionally, space colonies can contribute to preserving Earth's natural resources and promoting sustainable development. In conclusion, space colonization projects will create extensive economic and social impacts. These projects will offer new opportunities and challenges, playing a critical role in shaping humanity's future direction. Space colonization projects represent a significant step in shaping humanity's future. In this section, We will explore the potential and possibilities of space colonization in the future. Let's imagine how life in space will evolve with scientific advancements and technological progress. Firstly, the future of space colonization will depend on technological advancements. Robotics and artificial intelligence will play a critical role in this process. To make human life sustainable in space, intelligent systems and autonomous robots will greatly facilitate construction and maintenance processes. For example, the infrastructure of a colony on Mars could be largely built and managed by robots. Advances in energy production and storage will also shape the future of space colonization. Advanced solar panels and next-generation batteries will be crucial for meeting energy needs in space. Additionally, innovative energy sources like nuclear fusion could play an important role in ensuring the energy independence of space colonies. The sustainability of life in space will also be supported by developments in biotechnology and genetic engineering. Genetically modified plants and microorganisms can be used for food production and healthcare services in space. These organisms, designed to withstand the harsh conditions of space, can enhance the efficiency of life support systems. In the future, space colonies may become accessible not only to scientists and engineers, but also to ordinary people. As space tourism develops, the experience of living in space could reach a broader audience. This will diversify the demographic structure of space colonies and create new social dynamics. Another important aspect of space colonization is the continued exploration of space and the discovery of new celestial bodies. Beyond Mars and the Moon, humanity may plan journeys to Europa, Titan, and more distant planets. These explorations will help us uncover the secrets of the universe and find new living spaces. The future of space colonization will also be shaped by international cooperation and peaceful purposes. The importance of joint work in space can strengthen the culture of peace and cooperation on Earth. Colonies established in space will symbolize humanity's ability to achieve great goals through collaboration. In conclusion, space colonization is poised to be one of humanity's greatest adventures in the future. It will be exciting to see how life in space will be shaped with technological and scientific advancements. Future generations will witness the realization of these dreams, and perhaps establish new homes in the depths of space. Today we have taken a journey through the fascinating world of space colonization projects. From the Moon to Mars, from asteroids to Europa and Titan, this expansive vision represents just the beginning of humanity's future adventures. Space colonization offers both significant challenges and extraordinary opportunities. With technological and scientific advancements, achieving this goal becomes more feasible each day. International cooperation, economic opportunities, and social and cultural impacts lay the foundation for new life in space. Humanity's spirit of exploration and desire to understand the unknown drive us towards the depths of the universe. Perhaps one day, our children and grandchildren will sustain their lives on the Moon, Mars, or more distant celestial bodies. This vision, transcending science fiction films, has begun to turn into reality. The topics we covered in this video show how extensive and complex the efforts to sustain life in space are. Each step is a significant stride towards humanity's future in space. With the power of technology, science, and cooperation, these dreams are not far from becoming a reality. Don't forget to subscribe to our channel, like our video, and support us with your comments. Your feedback is very valuable to us. What topics would you like us to cover in our future videos? Let us know in the comments. See you in the next video, and stay with us on this journey into the depths of the universe.